MCP versus A2A protocol, understanding AI agent communication. Welcome to this technical deep dive comparing two fundamental approaches to AI agent communication, the Model Context Protocol, MCP, and the Agent-to-Agent Protocol, A2A. Understanding these architectures is crucial for anyone designing or implementing AI systems in today's interconnected digital landscape. Introduction to paradigms for AI communication. As AI agents become more sophisticated and widespread, the question of how they communicate and share resources becomes paramount. Today, we're examining two distinct approaches that solve this challenge in fundamentally different ways. Model Context Protocol, the MCP, the centralized hub approach. Let's start with the MCP protocol, represented on the left side of our diagram. The core architecture. In the MCP model, we see a centralized approach where a single AI agent sits at the heart of the system, connected to an MCP server that acts as the central hub. This server provides unified access to three critical external resources: databases for persistent storage, APIs for external services, and files for document management. Key characteristics of the MCP. The beauty of this architecture lies in its simplicity and control. The MCP server serves as a universal translator and gatekeeper, standardizing how the AI agent accesses different data sources. Whether the agent needs to query a database, call an external API, or process a file, it goes through the same standardized MCP interface. Benefits of the MCP approach. The centralized model offers several advantages. First, it provides consistent security and access control. All external interactions are governed by a single point of control. Second, it simplifies agent development since developers only need to implement one protocol interface. Third, it enables easier monitoring and logging of all external resource access. Agent-to-agent protocol, the distributed network approach. Now let's examine the A2A protocol shown in the upper right portion of our diagram. The mesh architecture. The A2A protocol represents a completely different philosophy. Here we see three agents, Agent 1, Agent 2, and Agent 3, all interconnected in a mesh network. Each agent can communicate directly with any other agent without requiring a central intermediary. Distributed intelligence. In this model, each agent maintains its own capabilities and can directly share information, delegate tasks, or collaborate on complex problems. Agent 1 might specialize in data analysis, Agent 2 in natural language processing, and Agent 3 in external API interactions, yet they can all communicate seamlessly. Advantages of A2A communication. This distributed approach offers remarkable flexibility and scalability. Agents can form dynamic partnerships based on the task at hand. If one agent fails, others can continue operating. The system can grow organically by adding new specialized agents without reconfiguring the entire architecture. The combined architecture, best of both worlds. The bottom section of our diagram reveals the most sophisticated approach, a combined A2A and MCP architecture that leverages the strengths of both paradigms. Hybrid system design. In this advanced configuration, we see two AI agents operating with A2A protocol capabilities while also having access to MCP servers for external resource management. This creates a multi-layered architecture that maximizes both flexibility and control. Agent 1 configuration. Agent 1 is connected to LangChain for advanced language processing capabilities and GPT for general AI processing, while maintaining access to an MCP server that connects to a database and local files. This gives Agent 1 both peer-to-peer communication abilities and standardized resource access. Agent 2 configuration. Agent 2 demonstrates a different specialization connected to LangChain, Claude, Anthropic's AI system, and its own database through an MCP server. This shows how different agents can have different tool stacks while maintaining interoperability. External service integration. The combined architecture also showcases integration with various external services. We see MCP servers connecting to web search capabilities, major cloud providers like AWS and Azure, and various communication platforms. This demonstrates the hybrid approach can scale to enterprise-level requirements. Practical implications and use cases. When to choose MCP? The MCP protocol excels in scenarios requiring tight control and standardization. Financial services, healthcare systems, or any domain with strict compliance requirements would benefit from MCP's centralized governance model. When to choose A2A? The A2A protocol shines in dynamic, collaborative environments. Research institutions, creative agencies, or any scenario requiring rapid adaptation and distributed problem solving would leverage A2A's flexibility. When to use combined architecture. The hybrid approach is ideal for complex enterprise environments where you need both the control of centralized resource management and the flexibility of agent collaboration. Large corporations, government agencies, or comprehensive AI platforms would benefit from this sophisticated approach. Technical considerations. Security implications. MCP offers centralized security control but creates a single point of failure. A2A distributes load but requires more complex security coordination. The combined approach addresses both concerns but requires sophisticated security orchestration. Performance characteristics. MCP can create bottlenecks at the server level but offers predictable performance. A2A distributes load but may have variable performance based on agent availability. The hybrid model requires careful load balancing and resource allocation. Development complexity. MCP simplifies individual agent development but may limit flexibility. A2A increases agent complexity but offers greater capability potential. The combined approach requires the most sophisticated development expertise but provides maximum capability. Future implications. As we look towards the future of AI agent communication, we're likely to see more hybrid architectures that combine the reliability and control of MCP with the flexibility and scalability of A2A protocols. The key is matching the architecture to the specific requirements of each use case while maintaining the ability to evolve as needs change. This comparison highlights that there's no one-size-fits-all solution in AI agent communication. The choice between MCP, A2A, or a combined approach depends on your specific requirements for control, flexibility, scalability, and complexity tolerance. Understanding these trade-offs is essential for making informed architectural decisions in the rapidly evolving world of AI systems.